In this video, we have some basics about our chemical reactions. So a little bit of vocabulary to go over, and then we're going to talk about two types of reactions. So first off, we have our reactants and our products. So reactants are the substances that we start the reaction with. So they are going to be our ingredients. So they're going to be written prior to the arrow. So down here in this example, here's the arrow. So that splits the reaction in half. So our reactants are HCl and NaOH. So if we were doing this as a lab, we would measure out the HCl, measure out the NaOH. So they're going to be our ingredients. Our products are what we produce. So it's what is made from the reaction. So it's going to come after the arrow. It's what you're going to end with. So the products of this particular reaction would be NaCl and water. So reactants are what you start with before the arrow. Products are what you make. They come after the arrow. We are going to talk about two types of reactions, endothermic and exothermic reactions. So first off, therm means heat. So these talk about heat. So therm means heat. In endothermic reaction, heat is absorbed. Heat enters. So in an endothermic reaction, heat enters. So therefore, heat would be a reactant. So heat would need to come prior to the arrow. So the reaction requires energy, requires heat in order to occur. Again, heat enters the reaction. So if there's not enough heat, the reaction will not occur. It's one of the necessary ingredients. Now, where the reaction draws in heat from is the surroundings. So the surroundings end up feeling cold because the heat has been absorbed. For example, you know how you have those cold packs that are in first aid kits? So those cold packs that are in first aid kits, you can't put ice in a first aid kit because it's going to melt. So what ends up happening is inside that cold pack, there's two chemicals. And when they mix, an endothermic reaction happens. When an endothermic reaction happens, heat has to go in. So these red arrows are showing me heat. So heat goes in. So let's say I hurt my shoulder at practice and I put one of those on. The reaction inside the bag draws in heat from my shoulder. That leaves my shoulder with less heat, so that leaves my shoulder feeling cold. Because my shoulder lost heat, the reaction inside the ice pack or cold pack drew in the heat. So an endo, heat goes in. So if heat comes before the arrow, it's an endothermic reaction. So H2O solid to H2O liquid, that's ice melting. In order for ice to melt, it has to draw heat in. So that's why when we put ice in our glass of water, it will make the water feel colder because as that ice melts, it draws in heat from the water, thus lowering the temperature of the water. All right, on the other hand, exothermic, heat exits. Heat is released or heat exits. So in exothermic, heat is given off. Heat is produced. So heat would come after the arrow. So here's the arrow. Heat would be a product. Heat would come after the arrow. This is going to make the surroundings feel warm because heat was released, such as one of those little hot packs. You know, those little hot packs that you can use skiing or at a football game where you shake it up and then it feels warm. How that works is, again, that's got two chemicals in it. When those two chemicals mix, it produces an exothermic reaction. When an exothermic reaction happens, it releases heat. So we release heat out to the surrounding. So if we're holding it, the reaction is going to release heat to your hand somewhere. This was chemical energy being converted to heat energy. So we still have law of conservation of energy, but it's one form of energy being converted to a different form of energy.